Building Information Modeling Applications. Applications in Professional Practice by Davis Marsh. Disaster Planning. Disaster planning provides emergency providers with important building information in the form of a 3D informational model system. By providing first responders critical building information, we could ensure quicker response time by reducing any confusion of building layout or function. Dynamic building information would be handled through a building automation system, known as BAS. While concrete information like the layout of the structure and its equipment would be laid out in the building information model, known as BIM. Both systems would be linked together so that emergency response teams would have the capability of accessing all the information they need, like high traffic areas in the building, exact location of said emergency, and the quickest route through the structure for quickest response time. Resources required. 3D model manipulation. In order to accurately represent real-time disaster relief solutions, you would need a team that could easily work with and manipulate a 3D model in real time based on altering environmental conditions to provide the most accurate and up-to-date information to first responders. Building automation system knowledge. Without an understanding of building automation systems, real-time information about the current state of different spaces of the structure would be lost. It is extremely important that the provider can accurately depict real-time information that is being recorded so that first responders can do their job in the most efficient way possible. Emergency response knowledge. Without proper training, the emergency response could be severely damaged. Even with extensive information about the location of emergency and the quickest route to personnel, lacking emergency response knowledge could ultimately create a failed rescue situation. Benefits and challenges. Some benefits would include quicker emergency response times, gives real-time building information to first responders, lowers risk to emergency responders. Some challenges would include must make quick, appropriate decisions during an emergency response, must have capable workers that could navigate and review BIM model for facility updates, must understand dynamic building information through BAS. Project examples. In Taiwan, modern high-rise buildings are configured in a way in which spaces are created in various ways. This creates a diverse building environment with various amounts of fire hazards that can be difficult to monitor. Developing an integrated fire prevention plan is extremely necessary to prevent disasters, and for a long time this plan has relied on human-provided intelligence. As we all know, our intelligence is limited and we are very prone to human error, like incompetence and poor communication. This can cause errors that could turn life-threatening. However, by combining building information modeling and wireless sensor networks, we can increase the accuracy and effectiveness of disaster response teams. This study discusses how Taiwan implements building information modeling to construct an intelligent fire prevention and disaster relief system. Some ways in which this system works. Bluetooth-based sensor networks to detect and transmit environmental data. Connect Bluetooth-based sensors and a mobile app to create faster personnel location. Plan optimal evacuation routes via Bluetooth-based sensors and mobile app. A building information modeling based system that increases evacuation rescue effectiveness. Site utilization planning, a process that utilizes 4D modeling techniques to present temporary and permanent facilities located on the site. By using a construction activity schedule, the 4D model can accurately interpret what facilities should or will be on site during different stages of the construction process. These facilities also include things such as materials and their deliveries, equipment location on the site, and labor resources. Having a 3D model that is also linked to a construction schedule gives us an accurate representation of the entire building process, sort of a visualized plan for the entire structure and its scheduling. Resources required. 3D model manipulation. For site utilization planning to work, a 3D model needs to be able to interact and communicate with a construction schedule. For this to be possible, a team capable of providing 3D modeling maintenance is extremely necessary. Design authoring software. In order for the 3D model to communicate with the rest of the building process, the design authoring software must develop the information into a building informational model. This helps refine criteria that is important to the translation of the building design. Scheduling software. Without a proper schedule to match with a 3D model, visual representations of permanent and temporary facilities on site would not be possible. Linking a scheduling software with a 3D model also gives the possibilities to track the building process from start to finish. 4D model integration software. This software is necessary to combine the information from a 3D model, a schedule, and a site analysis. By creating a mass of information in one location, we can expand the possibilities of visual representations of the building process. Detailed existing conditions site plan. By having an existing conditions site plan, the visual representation of the site development over the course of a project can help explain to the client the changes that will be made to the site. Benefits and challenges. Some benefits include visual representation of facilities and building process. Helps identify potential space conflicts on site. Update site organization and space usage as construction continues. Some challenges are: must be able to navigate and review 3D models. Must be able to manipulate and assess construction schedule with 3D model. Must understand typical construction methods. Project examples. A study done by two researchers in 2014 discusses CSUP, construction site utilization planning, and its potential to create a more efficient construction process by enhancing budget and schedule performance, while also improving the safety of the entire construction process. This study goes on to discuss how planning has usually been conducted, a combination of AutoCAD and PDF files. By combining building information modeling and construction site utilization planning, we can create a construction execution plan that can be effectively communicated to all stakeholders of said project. The researchers go on to further discuss the developments they believe need to occur so that building information modeling can work hand in hand with construction site utilization planning. They also discuss the benefits of integrating site utilization planning with construction schedules to produce high-quality 4D simulations of construction projects and how it is being utilized in the industry currently.